Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today I am going to discuss a class 9 topic. The name of the chapter is Matter in our Surroundings, Part 10. And the name of the topic is Previous Year Cbse and Olympiad Questions. Children, these questions are very important for you because these questions will help you in strengthening your concepts. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads and press the like button if you like this video and share this video with your friends also. So now come with me and let's crack chemistry. Now I will discuss previous year Cbse and Olympiad questions. Students, in the previous video I have discussed 10 questions. In this video also I discuss next 10 questions. So question number 11 is that vapor term cannot be used for which of the following gases? Students, before solving this question, I would like to make clear the difference between vapors and gases. Vapor exists in solid or liquid state under ordinary conditions of room temperature and pressure. For example, iodine exists in solid state under ordinary conditions of room temperature and pressure, but on heating it converts into vapor. Similarly, water at ordinary temperature and pressure exists in the liquid state, but when its molecules gain energy, it converts into the vapor state. But gases exist in the gaseous state at room temperature and pressure. So if we look at the options which are given here, options are given as hydrogen, nitrogen and carbon dioxide. You all know that all these three substances exist as gaseous state under ordinary conditions of room temperature and pressure. So we cannot use the term vapors for any of the gas which is mentioned here. So our correct option is all of these, means we cannot use the word vapor for hydrogen, nitrogen and carbon dioxide gases. Now question number 12. Which of the following has the highest rate of diffusion? Students, we have discussed this in our previous video. Children, diffusion means movement of particles from a region of higher concentration to lower concentration. So it means diffusion is associated with the movement of particles. Now you can correlate diffusion with the type of particles in solid, liquid and gaseous state. As you know that in case of solid state, the particles are very closely packed. So they don't have freedom of movement. They can only vibrate or oscillate about their mean position. So solids have least diffusion. They have negligible diffusion. But in the case of gaseous state, as the particles have complete freedom of movement, so they have highest rate of diffusion. So our correct option is gaseous state. Option C is the correct option. Next question. Gases have, children, they are talking about shape, size and volume. So you already know this, we have discussed in our previous videos in very detail that gases neither have fixed shape, size nor they have fixed volume. So they don't have fixed size, shape and volume. So if we look at the options, option first is not the correct option because it is showing fixed shape. So first option is the wrong option. If we look at the option B, they are saying that shape and size fixed. So this option is also a wrong option. Option C, volume and size fixed. So option C is also a wrong option. So a correct option is none of these. Option D is the correct option. Now question number 14. Question 14, they are asking which of the following is fifth state of matter. Children, you know that there are three common states of matter which are also called as basic states of matter. Basic states of matter are solid, liquid and gaseous state. Apart from these three basic states, there are two more states which are not very common states. So these states are plasma state. Plasma state is called as fourth state of matter and BEC. BEC represents the Bose-Einstein condensate. which represents fifth state of matter. It means our correct option is option C, BEC. BEC stands for Bose-Einstein condensate. Children, I would like to give you some more information about BEC. The existence of this state was predicted by two scientists, Satyendranath Bose and Albert Einstein in 1920. But they could not make it happen because of the lack of equipment and lack of facilities. They predicted it, but they could not make it happen. They could not create it. So this state was created in 1995 by two scientists. Cornell and Wieman created fifth state of matter, which is Bose-Einstein condensate, in 1995. Now I would like to discuss some more about BEC. Children, in contrast to plasma state, which exists at a very high temperature, plasma state consists of super hot and super excited atoms, but BEC consists of super cold and super unexcited atoms. It means this state can be created at a very low temperature, 0 Kelvin, which in terms of Celsius scale is equal to minus 273.15 degrees Celsius, is the lowest possible temperature. At this temperature, all molecular motion stops. Fifth state of matter, which is BEC, can be created at a temperature which is very close to 0 Kelvin. This state can be created by some special elements which have very low density. Cornell and Wieman created this gas by using rubidium. The symbol of rubidium is Rb. I hope it is clear to you. Next question is, which of the following is an example of artificially produced plasma? Children, before discussing this question, first of all, I would like to give you some information about the plasma state. Plasma state is different from the gaseous state. Gases consist of atoms in which electrons are bound to the nucleus of the atom. But in case of plasma state, electrons are lost by the atom. They consist of positive ions and the negative electrons. The negative electrons move around the positive system in case of plasma state. There are two types of plasma. One is the natural plasma and another is the artificial plasma. Few examples of natural plasma are northern lights. In this picture, you can see northern lights. You can see it's such a beautiful scene. So northern light consists of plasma. Another example is ball lightning. In this picture, you can see ball lightning. So ball lightning is also an example of natural plasma. Other examples of natural plasma are sun and stars. You can see natural plasma on sun and stars also, where very high temperature exists. Now I will like to discuss few examples of artificial plasma. Artificial plasma includes fluorescent bulbs and neon signs. Now I will discuss how plasma state differs from the gaseous state. Children, gaseous state consists of atoms in which electrons are bound to the nucleus of the atom. But in case of plasma state, electrons are lost by the atom. So plasma state consists of free electrons which move around the positive system. In the previous question, we have discussed about BEC, which consists of super unexcited and super cold atoms, but here we have super excited and super hot atoms. Now I would like to discuss about artificial plasma. Children, common examples of artificial plasma are fluorescent bulbs and neon signs. Fluorescent bulbs are not like the ordinary bulbs. They consist of a tube in which a gas is filled. When electricity is passed through the gas which is present in the tube, the electricity charge of the gaseous atom. As a result of which, electrons will be lost by the atom and the free electrons will move around the positive system. Similarly, neon signs also have the similar functioning. In neon signs, an inert gas, mostly helium, neon, argon, krypton or xenon, is taken in the signs. So when electricity is passed through the signs, the electricity will cause the excitement of atoms, as a result of which electrons will be lost by the atom and the free electrons will move around the positive system. Now I am coming back to the options which are given in this question. Given options are solar wind. Solar wind, as you know, is an example of natural plasma. Rocket exhaust. Rocket exhaust is not an example of natural plasma. It is an example of artificially produced plasma. So our correct option is option B, which is rocket exhaust. I will discuss the other options as well. Option C is sun. So you know that sun is an example of natural plasma. And fourth option is interstellar nebulae. This is also an example of natural plasma. In this picture, you can see a few more examples of plasma. This is the picture of northern lights. Lightning is also an example of plasma, and the sun is also an example of plasma. I hope it is clear to you. Now question number 16. Which of the following has the highest energy? I think you will not take much time to answer this question because given options are solid state, liquid state, gaseous state and plasma state. So our correct option is plasma state because plasma state consists of atoms which are super excited and super hot, as a result of which plasma state will have the highest energy. So our correct option is option D, which is plasma state. Now question number 17. Fusion is the process of change of. Children, this topic also I have discussed in my previous videos in detail. Fusion involves conversion of solid into liquid state. So option C is the correct option. Fusion involves conversion of solid into liquid state, and the process of fusion is also called as melting. Now question 18. Intermixing of two or more matter on their own is called as diffusion. So correct option is diffusion. Diffusion is the process of intermixing of two or more matter on their own. All of you have seen that when you add few drops of ink in water, after some time the whole of the solution get colored because of the process of diffusion. Now next question, question number 19. Which of the following is an example of bulk phenomena? Children, this also we have discussed in our previous videos. Boiling is an example of bulk phenomena because boiling takes place in bulk. Now I am going to discuss the last question. At the boiling point of any substance, what happens? Children, at boiling point of any substance, the vapor pressure of that liquid becomes equal to atmospheric pressure. So when vapor pressure of any liquid becomes equal to atmospheric pressure, the whole of the liquid starts boiling. So our correct option is option C. Vapor pressure is equal to atmospheric pressure at the boiling point of any substance. Children, thank you so much for watching this video. I hope each and every point is clear to you. Please subscribe my channel and press the like button if you like this video, and share this video with your friends also. Thank you so much. Have a nice day.